So it only contains multiple choice problems, and I'm just going to run down through a list of topics that is going to be in this video. We're going to talk about one-dimensional kinematics, speed, velocity, acceleration, displacement, things like that. Also graphs of linear motion. We're going to talk about projectile motion, vectors, and then we're going to go into forces, Newton's law of motions, free body diagrams, inclined planes, pulleys, friction, tension force, normal force, stuff like that. And then we're going to move on into circular motion, gravitation, centripetal force, work and energy problems, kinetic, potential energy, mechanical energy, conservation of energy, linear momentum, inelastic, elastic collisions, impulse momentum theorem, rotational motion, torque, inertia, angular momentum, and other topics in those chapters. So just want you to know what topics will be in this video in case you may have to study for topics that this video might not cover. So let's go ahead and begin. By the way, I recommend that you pause the video and work out each problem yourself before viewing the solution. The best way to learn is by doing the problems. So just make sure you pause the video, and once you finish, unpause it to see if you have the right answer. So let's go ahead and begin. Number 1. A car travels 200 miles east in 4 hours and then 300 miles west in 5 hours. What is the average speed of the car for the entire trip? Average speed is equal to the total distance divided by the total time. So what's the total distance in this problem? The car traveled 200 miles east, and then it went 300 miles west. So it traveled a total distance of 500 miles. And the total time is 4 hours plus 5 hours, so that's 9 hours. So all we got to do is take 500 and divide it by 9. So the average speed is 55.6, or 0.5 repeating, miles per hour. So that's the answer. It correlates to answer choice D. Number 2. A car travels 200 miles east in 4 hours and then 300 miles west in 5 hours. That's supposed to be an S. What is the average velocity of the car for the entire trip? So, how is this problem different from the last problem? How can we calculate the average velocity of the car? The average velocity is equal to the displacement divided by the total time, as opposed to the total distance over total time. So what is the displacement of the vehicle? Well, we know it travels 200 miles east, and then it travels 300 miles west. You need to understand that distance is a scalar quantity. It can only be positive. Displacement is a vector. It can be positive or negative. So the displacement for the first part of the trip is positive 200 because it was going in a positive x direction. And then going west, it's negative 200. So if we add these two values, the net displacement for the entire trip is negative 100 miles. Because we started here, and the net result, if you look at the initial position to the final position, the car traveled 100 miles west. Now the total time is still 9 hours. So it's going to be negative 100 divided by 9. And so this is going to be negative 11.1 miles per hour. So keep this in mind. Speed is always positive, but velocity can be positive or negative. Velocity is a vector. It has magnitude and direction, but speed is a scalar quantity. It has magnitude only. So D is the right answer. Number 3. A car accelerates from 15 meters per second to 45 meters per second in 9 seconds. How far does the car travel during this time period? Now for these types of problems, you may want to make a list of what you know and what you need to find. So we're given the initial speed is 15 meters per second. We have the final speed, which is 45 meters per second. and the time period is 9 seconds. Our goal is to find the distance that the car travels, or its displacement. Distance and displacement is the same whenever the car travels in one direction, if it doesn't change direction. The equation that we need that has all of these variables is this one. It's 1/2 v initial plus v final multiplied by t. So you can only use this equation if the car is moving with constant acceleration. It can't be moving with constant speed. So it's going to be 1/2 the initial speed plus the final speed multiplied by the time. 15 plus 45 is 60, and 60 divided by 2 gives us an average speed of 30 meters per second. 30 is the average between 15 and 45. So it's going to be 30 times 9. 3 times 9 is 27, so 30 times 9 is 270. So it's 270 meters, which means C is the right answer. Number 4. Which of the following statements is not true concerning a ball in projectile motion that was kicked horizontally off a 200-meter cliff at an initial speed of 15 meters per second? So go ahead and try this problem. So let's begin with a picture. So here's the ball. It's kicked horizontally off a cliff, and it follows this trajectory. So the initial speed is 15 meters per second, and the height of the cliff is 200 meters. So which of the following statements is not true? So let's start with A. The initial vertical velocity, is that 0? At this point, the ball is moving in the x direction. It's not moving at an angle. It has no y component. So whenever an object is moving horizontally, the vertical speed is always 0. The only way the vertical speed will not be 0 is if it's moving at an angle, if it's moving straight up, anything but horizontal motion. So anytime it's horizontal, Vy is 0. So A is the true statement. Now what about E? The horizontal speed is constant. Is that true or false? And what about B? The horizontal acceleration is negative 9.8 meters per second squared. Now, whenever you have an object that's moving in projectile motion, by definition, the only force acting on the object is gravity. So there's no air resistance, nothing else. So therefore, gravity only acts in the y direction. So we have a vertical acceleration of negative 9.8 due to gravity. Since gravity is the only force acting on an object in projectile motion, by definition, there is no horizontal acceleration. It has to be 0, which means B is a false statement. The horizontal acceleration is not negative 9.8. That's the vertical acceleration. That's AY. AX is the horizontal acceleration. Now, E is a true statement because if the horizontal acceleration is 0, then the velocity, Vx, is constant, which means the horizontal speed is constant as well. Now, since Vx is constant, that means C has to be a true statement. So let's call this point A, point B, and point C. Because Vx is constant, everywhere along this trajectory, the horizontal speed will be 15 meters per second. That's not going to change. Anytime the acceleration is 0, the velocity will be constant. And so the horizontal speed is always 15 meters per second everywhere along this curve. Now what about D? D is also a true statement. Notice that the vertical acceleration is negative 9.8 meters per second squared. The acceleration tells you how much the velocity changes every second. So because AY is negative 9.8, that means the vertical velocity will change by 9.8 meters per second every second. The negative sign tells us that the velocity will decrease by 9.8 meters per second every second. Now, on the other hand, AX is 0, which means that the velocity in the x direction does not change, which explains why Vx is constant. So therefore, the only statement that is not true is statement B. The horizontal acceleration is not negative 9.8. It's 0 whenever you're dealing with projectile motion. So make sure you keep this in mind. For projectile motion, AX is always 0. AY is negative 9.8, always. Vx will always be constant. And Vy is 0. Let's say if you're going in this direction, at this point Vy is 0. Anytime you have an object moving in the x direction, Vy is 0. So if you get a projectile that looks like this, at the very top, the vertical speed is 0 because it's moving horizontally at that point. And keep in mind that Vy changes by 9.8 meters per second every second. So if we're dealing with velocity, the vertical velocity always decreases by 9.8 meters per second every second. Number 5. A ball is released from rest at the top of a 450-meter cliff. How long will it take the ball to hit the ground? So let's start with the picture. That's the cliff, and here's the ground. So it's 450 meters high. So here's the ball. Now it's released from rest, which means that the initial speed in the y direction is 0. How long will it take for it to hit the ground? What equation should we use? We can use this equation. The displacement is equal to v initial t plus 1/2 at squared. Now we're dealing with the vertical displacement, so we need to use the initial vertical speed and the acceleration in the y direction. The displacement in the y direction as we move from position A to position B is negative 450 because we're going in a negative y direction. Vy initial in this problem is 0, and the acceleration in the y direction is negative 9.8. So what we have is negative 450 is equal to negative 4.9 times t squared. So negative 450 divided by negative 4.9, that's positive 91.837, and that's equal to t squared. Now let's take the square root of both sides. So t is 9.583 seconds, which means E is the answer. Number 6. A ball is thrown downward with an initial speed of 25 meters per second from the top of a 500-meter building. How long will it take the ball to hit the ground? So in this problem we have the same picture, but this time the ball is thrown down with an initial vertical speed of 25 meters per second. And the height of the building is a little bit different. It's 500 meters this time. However, we could use the same formula to calculate the time. So the vertical displacement is going to be equal to the initial speed multiplied by the time plus 1/2 at squared. Now the displacement in the y direction as we move from position A to position B is still negative. It's negative 500 in this example. And the velocity in the y direction is negative as well because the ball is moving in a negative y direction. So this is going to be negative 25 times t. And A is negative